Okay, so we have a bottle that contains a mixture of milk and water in the 7:2 ratio, and bottle 2 contains mixture of milk and water in 9:4 ratio. Now, in what volumes should the liquids in bottle 1 and bottle 2 be combined to obtain a milk mixture of milk and water, which is in the ratio 3:1? Now, the general tendency of these questions is to solve via allegation, which is correct. That's not wrong. But let me show you a faster method here. So we have something like this. Let me just draw this chart to explain this better. And the required is something like this, right? So let me keep a gap here because I'm going to use this space for explanation purpose. Now, first thing that you should be able to identify is that because it's a ratio related question, you will have options, right? So how to utilize the options. So this is a very fast method. If you understand this properly, whenever it's a ratio related question, there will be options. There will be no way to actually input the ratio. So what you can do is you can just try to imagine it in this way. Let us assume that these are the actual volumes that you have in the first bottle and the second bottle. So if you have that, then what is the total volume that you have? So if you consider the total volume, you have 9 here and 13 here, right? Now, effectively, what will happen is you will take some parts of this or some multiple of this and some multiple of this and mix it to get the answer. Now, what I mean by that is, if you mix it in the ratio 9:13, let's say, if you mix the bottle 1 and bottle 2 in the ratio 9:13, then all you're doing is you're mixing this 7 and 9 to get 16, and this 2 and 4 to get 6 to get this particular ratio, which is 8:3, right? It's not 3:1. So this was just an example to explain what I'm going to do. So we can work around the allegation process and directly use the ratios to figure out the answer with the options, of course. Now, first thing that you're going to notice in this question is whatever ratio has been given. So consider this. I mean, this is bottle 1 is to bottle 2, right? That is what the question is asking for. What ratio the volume should the liquids in bottle 1 and bottle 2 be mixed? So if you take this perspective, this is some 9K and this is some 13L, right? So I'm not going to use this very well. I'm just writing this to explain whatever is happening. So you should have the ratio something, I mean, looking something like this, right? Now, until unless there is some cancellation happening, this part will be a multiple of 13 and this part will be a multiple of 9. You should be able to observe that every option, you have the first part definitely a multiple of 9, right? So the second part, wherever you have this multiple of 13, try to test that first. So you have to test it out. So test this option first because this has a multiple of 13 in it, isn't it? So if we go with this, so what are we actually doing? So this is already 13, so nothing needs to be multiplied. You just have a 1 multiplied here. So effectively, you're multiplying 1 to both of this. That's it. But in order to convert this to 27, you're actually multiplying a 3 here. So in order to do that, you need to multiply 3 here and you need to multiply 3 here because this is the total volume and milk and water is in this proportion. So whatever the total volume gets multiplied by, the milk and water proportion also gets multiplied by the same factor, right? So now just test this out, whether we are getting this 3:1 or not. So we have 21 liters of milk here and 9 liters of milk here. To add, we get 30 liters of milk. We have 6 liters of water here, 4 liters of water here. So you add, you get 10 liters of water. And this is precisely hitting on 3:1, right? So this is it. So that's it. We get the answer. So what are we mixing in? We're mixing in the ratio 27:13. That is option B. So if you understand this idea, you will test the option that is the most logical one. And if you do that, then it doesn't take too much time. Otherwise, of course, you can apply allegation into it. Let's say, I mean, all the options had multiples of 9 and all the first parts had multiples of 9, the second parts had multiples of 13. In those cases, you can definitely apply allegation. But using allegation, this will be a little calculative in nature. It would not be very easy to solve. You would be working with fractions like 7 by 9, 9 by 13, 3 by 4. then each of them have different denominators. So that might be a little more time consuming. So this question, the ideal time to solve, because if you understand this idea, then the ideal time to solve this question would be roughly 1 minute, or let me say 1 to 1.5 minutes. So depending on your comfortability with this particular idea here. So that's it for this question. I hope this idea was understood. If the question and I mean let me explain a bit on the power of this idea. Had the question been the other way around, so the milk and water ratio is given. Again, the milk and water ratio is given, and it's mentioned in what ratio you are mixing the two bottles. In that case, there is no question of options. Also, in that case, never use alligation. Use this process. Just make the volumes in a way that that fulfills the ratio. If you have a problem, then just get it to 1:1 first, and then multiply the the corresponding parts. This is something we have detailed. We have explained in a very detailed manner in our classes. For this video, I cannot invest that much time. But then just try to work with that particular ratio. Try to make the volumes correspond to that particular ratio. Then you will get this answer stream simply by adding the milk and adding the water, and that will be much faster than anybody else can do. So this is a very easy way to look at these kind of problems. I hope that was understood. So thank you.